Have you ever heard the saying, the answer is only as good as the question? Throughout history, good scientific questions have led to important discoveries. But what makes a good question? Researchers use the scientific method to explore the kinds of questions that can be tested and answered. The steps usually include making an observation, then asking a question based on your observation, forming a hypothesis, or making a prediction based on what you already know or have researched, deciding what method you will use to test your prediction, conducting an experiment and recording the results, making conclusions based on the results of the experiment, and completing an evaluation of your results and asking others to evaluate them. A good scientific question builds on something you already know or have observed. For example, you know that crops need rain to grow. So, a good question might be, what is the optimal amount of water for soybeans to grow? And let's say your hypothesis is, the more water the soybeans receive, the taller they will grow. What method could you use to test this prediction? If you're growing soybeans in the lab, you would have to grow each plant in similar conditions, including consistent temperature, adequate space, and the same number of hours of light each day. These are your fixed or controlled variables. By controlling all the other possible independent variables, keeping them steady, you can ensure that the results you get are based on the amount of water the plants receive. An independent variable is the factor tested in the experiment. It is the one you change. In this case, your independent variable is the amount of water. The variable you're trying to measure is called the dependent variable, which in this experiment is the height of the soybeans. In other words, your experiment depends on the variable you are changing and how you change it. It looks like soybeans that receive little water did poorly, but so did the plants that got a lot of water. The plants in the middle grew tallest. Based on your data, you conclude that these plants need moderate rainfall to grow best. Now it is time to write up your results. How would you evaluate this experiment? The data did not support your hypothesis, but that doesn't mean your results aren't important. Both you and the others you communicate your results to can benefit from them. What great question will you try to answer next? Here's one. What is the response of brine shrimp to light?